Hello physicists, in this video we're going to explore the multiplication of a vector by a scalar. Okay, so if you remember, a vector is a quantity with both magnitude and direction. Okay, so let's say we have vector A. We specify its magnitude by the length of the arrow and we specify the direction by the direction the arrow is pointing. Okay, so the arrow itself tells the direction, the length of the arrow tells the magnitude of A. Now, what we're going to do is see if we can multiply a vector by a scalar. So let's say we have some scalar k. Okay, k is a scalar value. So if we multiply k by a, what will be the result? All right, so if we multiply if we multiply the vector a by the scalar k, then the vector gets stretched. It changes by a factor k. So if k is positive, greater than 0, then the length of the vector, magnitude of the vector, is k times the magnitude of the original vector. Okay? So the magnitude of, k times a is k times the magnitude of the original. Right? So this vector is noticeably longer. Okay? If 0 is less than k is less than 1, so k is a fractional quantity. K is a fraction, and remember, scalars can be anything. They don't have to be just integers. They can be rational numbers, real numbers as well. Okay? So we have vector A again. Then k will be shortened. Sorry, A will be shortened. This will be ka. See how it's shorter? Because we're multiplying by a fraction. And multiplication by a fraction reduces the quantity of the number. The product, when multiplied by a fraction, is smaller than the original number. Okay? And if we multiply by 0, if k equals 0, 0 times a will be the 0 vector. Nothing. So just like normal math, nothing at all. So if k equals 0, we have the 0 vector. Now what happens if k is negative, if k is less than 0? Well, the same rules apply, except if we have vector a, and we multiply by -1. We have vector a and multiply by -1. -1 times a, we get the negative vector. And that is just the opposite direction of our original vector. So the magnitude of -a remains the same, but the direction is flipped. Such vectors are known as anti-parallel. And we use this special name because even though these lines never touch, they're in completely opposite directions, or anti to each other. So you have vector a and negative of vector a. So if we have -3a, so we have a vector a, our same vector. What would -3a be? Now, consider it this way. Because it's negative, we're first going to have to flip the vector. This is just -a, and then stretch it out by a factor of 3, because 3 is greater than 1. Okay? This should be 1. 3 is greater than 1, So we have a much more elongated vector, but pointing in the opposite direction. This will be negative 3a. Note that when you're multiplying a vector by a scalar, the result is a vector. Okay, it's not a scalar. The scalar just stretches or shrinks the magnitude of the vector. It stretches out or squeezes in the actual arrow. Thanks for watching. See you in the next video.